Hey guys, hope you're doing fine. My name is Nishant and we are at day 24th of May LeetCoding challenge. Let's look into our question. Construct binary search tree from preorder traversal. Return the root node of a binary search tree that matches the given preorder traversal. Okay, it's guaranteed that for a given test cases there is always possible to find a binary search tree with the given requirements. Okay, so what a binary search tree is: a simple binary tree with a condition that the left child will always be smaller than the root and the right child will always be greater than the root, and it's true for every node recursively. Okay, so given a pre-order traversal of a binary search tree, we have to construct the binary search tree. Okay, so let's look how we do that. Here is our logic to build the binary search tree. We will do by iterating over the pre-order array and checking where should it lie in the binary search tree, that is on the left subtree or the right subtree of a particular node. Okay, so we will build the left and right subtree recursively for each element in the preorder traversal. Okay, so here is our preorder traversal given in an array 8, 5, 1, 7, 10, 12. These are the elements of the binary search tree. So we call the function build tree by passing the preorder array and the first index of the preorder traversal and the range int min and int max, since the root of the binary search tree can be any number between this range, that is -infinity to +infinity. Okay, since it's a preorder traversal, it's what is preorder traversal? First we traverse root, then we traverse the left subtree, then we traverse the right subtree. So the first element of this array will always be the root of our binary search tree. So 8 is the root. Okay, so this now we go to the left subtree of 8 and build the remaining left subtree of our binary search tree. Now p index is incremented to 1 and int min is -infinity. Now max will be our 8. Since all the elements on the left subtree should be less than 8, okay, so the max it can have value is 8 or less than 8, that is 7, up to 7. So what is the value at index 1? It is 5. So now we check if 5 is in this range. Yes, it is in this range. So we simply build a new node and make it the left child of 8. Okay, so now we go into recursion of 5 to its left subtree. Now p index is also incremented to 1. Int minimum will be -infinity and int max will be now 5. Okay, and the value at p index is 1. We check if 1 is in this range. Yes, it is in this range. We make 1 the left child of 5. Okay, so now again we go into recursion for 1 to its left subtree. So p index is now 3 and the int min is -infinity and int max will be 1. The value will be 7. The value at index 3 is 7. So we check if 7 is in this range. No, it is not in this range, so simply it will return null to this. Now this 1 will go into recursion to its right subtree. Okay, so now the p index is 3 and what will be the int max? Int max will be 5. Okay, because at this level of recursion the int max is 5, so 5 will be passed on to the next call and okay, sorry, 5 should be the maximum and minimum should be 1. And we check if 7 in this range. No, it is not. again it will return null to 1. Now the once left and right both calls are finished, it will also return null to 5. And now 5's right subtree call will begin. So here, and so it's the 5's right subtree call, and the value of p index will be still 3. And since it's the right subtree call, so the minimum value will be 5 and the max value will be 8. Since 8 is the max at this level of recursion, and it will pass to the next call. Okay, so the value is 7. We check 7 is in this range. Yes, it in this range, so we append 7 as the right child of 5. Okay, now 5 has also completed its both calls for left and right subtree. Now it will return to 8. Okay, now 8 will resume its call to the right subtree. Okay, so right subtree. So now the p index value will be incremented by 1, that is 4, and int min will, since it's the right call, the minimum value will be 8 and the max value will be infinity. Since int max is the value of max at this level of recursion, it will be passed to the next call as well. And the value at index 4 is 10. Okay, so we check if 10 is in this range. Yes, it is, so we append 10 as the right child of 8. Okay, so this is done, and we go into the recursion to the left child of 10. So the value of index will be 5, and since it's the left child, we simply pass 10 here. Okay, sorry, the minimum will be 8 and the max will be 10 here. Okay, so what's the value? Value is 12. Now we check if 12 is in this range. No, it is not. Then it will return simply to this call, and this call will resume its function for its right child. Okay, so now the p index is 5 and it's the right call. The minimum will be 10 and int max will be whatever is the maximum at this level, that is infinity. The value is 12. We check if 12 is in this range. Yes, it is in this range, so we append 12 as the right child of 10. Okay, and now we go further. P index is now 6 for the left child of 12. Now since 6 is equal to the size of array, we simply start returning. So this call will return to this will return to 10, and 10 will be returned to 8, and 8 will return its call to the first call of the function. So this is how you build the binary tree. And so this is the index. This is the base condition. If the size of preorder array becomes equal, if the p index becomes equal to the size of preordered array, we simply return null. Okay, and let's define a function build tree. We'll take this preorder as parameter and p index and int min and int max values. We check if p index is equals preorder dot size, we return null, and check int value will be preorder of index. This will be the value at the p index. We check if value is not in the range, we simply return null. Okay, so if it is in the range, we build the left subtree. Okay, first we need to create a new node, tree node. Let's name it root, and we create a new node here, and that is value. Okay, so this is how we get the root or a new node, and now we increase the index position and keep building the left and right subtree. Okay, just pass preorder, and index, since it's the left subtree, minimum will be same and max will be the value. Same for the right subtree. This time minimum will be the value of that current node and max will be the same. And after all the recursive calls, just simply return the root. Okay, so this is it. We return here our build tree function with, and the preorder p index will be 0, this will be int min, and max will be int max. So this is good, this should run. Just run this, compile preorder, will be spelled 17th. And that's not code. Okay, small p. Okay, passing argument to parameter p index here. Temporary. Okay, so int p index equal to 0. Should do. You cannot pass directly 0 to a address referenced variable. So this is good. Submit it. Guys, it's accepted. Link for the codes in the description. Thanks for watching. See you next time.